All right, guys, are there any questions over the assignments? So we've had 7-1, 7-3-1, and 7-3-2. So we've had 3 assignments thus far. If there are no questions on those, what we're looking at today is addition and subtraction, adding and subtracting these rational expressions. Now, whenever we add or subtract 2 fractions, the denominators need to be the same. If the denominators are the same, we can add and subtract, and we add and subtract the numerators together, and the denominators stay the same. So if we look at the first example here, 7 over 4x plus 3 over 4x, well, the denominators are the same, and it is 4x. So what we need to do is add the numerators. So we would be adding 7 plus 3. Well, 7 plus 3 would be. Now, once we finish adding or subtracting, we do need to make sure we cannot simplify the top and bottom. And here, well, the 10 and 4 do have a common factor between them, which is 2. So the 10 would simplify 2, and the denominator would simplify 2, 2x. So this here would be our answer. Any questions on A? Let's look at B. So we have 2x over x plus 6 minus 5 over x plus 6. Well, since the denominators are the same, here we can subtract the numerators. So we would be taking 2x minus 5. Well, we need to see if we can simplify or factor the numerator at all. And well, 2x minus 5, there's no greatest common factor. And since they are being subtracted, we consider it as one whole term. And well, it's not like the denominator, so, well, that there is as simplified as it gets. You don't have to, but it is a good idea, I mean, just to be thinking of those as one term. Because I've seen it happen on many different occasions where people want to just cancel out the x and x. Because we can't just cancel out the x and x or the 2 and 6 because those are one whole term. Any other questions on this here? Well, we can look at number 1 here. 8 over 12x minus 5 over 12x. Now, 8 and 12 do have a greatest common factor, yes? But what do we need to be able to subtract? We need the denominators to be the same. So we don't want to mess with that yet. So we'll leave it as 12x. 8 minus 5 is? So we have 3 over 12x. Well, we do have something in common on top and bottom, 3. And we can simplify this down to 1 over 4x. And that is perfectly fine. Now this here is different than the one we had before, because if we look at the top, we have 2x minus 5, on bottom x minus x plus 6. Those are 2 terms being combined with addition and subtraction. Here, the 3 and 12x, that's only one term. It's one term by itself, so it is a different setup, a different case. Number 2, well, the denominators are the same, so we have 3x. On top, we can add the numerators. 2 plus 1 is. Now this will simplify too. 1 over x squared, because the 3 over 3 would simplify to 1 over 1. And we don't write the 1 on bottom because we already have the x squared. So this here would be our answer. We won't worry about number 3. Let's look at number 4. Now again, for this one here, the denominators are the same. We do have x squared plus 1. In the numerators, we would have 2x squared plus 2, because we can add those together. Is there any way that we could factor any part of this here? X squared plus 1 doesn't factor, but the numerator has a greatest common factor of 2, which we can factor out. And if I factor 2 out of 2x squared, I'm left with x squared plus 1. And this would be over x squared plus 1. Well, do we have something in common on top and bottom now? So that would simplify out, leaving us with what? So here the answer is 2. So even though it doesn't look like it could factor or simplify, we do need to pull out greatest common factors and simplify. On some, it might turn out that there was no greatest common factor on top and bottom, but it's still helpful to factor it down and see, just to make sure. Just like this here, it ended up being 2, because there was a greatest common factor of x squared plus 1 on top and bottom. Any other questions on this here? All right. Well, not every rational expression will have like denominators. We're going to have a good number that don't. And for us to be able to add or subtract them, we need to make the denominators be the same. Because if they're not the same, we're not going to be able to add or subtract them together. Now to do that, what we're going to end up finding is what we call the least common multiple. The smallest thing we can turn both sets of expressions into to be able to add or subtract. So the first thing we're going to really look at is finding least common multiples between two things. So when we look at these two things, to find the least common multiple, the best thing to do is going to be to factor them. So the 4x squared minus 16 and our 6x squared minus 24x plus 24. So it's going to make this a lot easier to work with if we have these factored down. Now when we look at either one of these here, the first thing we need to find is a greatest common factor. So if we look at 4x squared minus 16, is there a greatest common factor between these two terms? Well, yes, it would be 4, and we could factor it out. So if I factor a 4 out of 4x squared, I'm left with x squared minus 4 factored out of 16 would be 4. Now, are we able to factor the x squared minus 4? Well, yes, and it is one of our special ones, because that is a difference of perfect squares. And that would factor 2, and x plus 2, and x minus 2. And that would be completely factored. Now let's look at the other one, 6x squared minus 24x plus 24. Is there a greatest common factor between these three terms? 6. So we can go on and factor it out. So if we factor the 6 out, what we're left with is x squared minus 4x plus 4. We're dividing each term by 6. Now that we factor the 6 out, we'll still need to factor the x squared. The x squared minus 4x plus 4. Since the third term is positive, the signs are the same and match the sign of the middle term, which would be negative and negative. Now we need to find the factors of x squared, which would be x and x. And the factors of 4 would be 2 and 2. So we do have these factored down completely. which leads us to find the least common multiple. So when we find least common multiple, really we're wanting to find the smallest thing that we can turn both expressions into. What do we need to do to make both of these expressions be the exact same? Now the first thing I would look at is the 4 and 6. Now there's two ways we can look at this. One of them is rewriting these as a prime factorization, breaking it down into a multiplication of their smallest parts. Well, 4 is 2 times 2, because that's the smallest I can do it as a multiplication of prime numbers. 6 is 2 times 3. Now for each prime number, we look at both of them and grab the number of 2's or 3 that occur the most in each one. So when we look at 2's, 4 has 2 and 6 has 1. So we want the most from either number, which would be 2. So for our least common multiple, we'll need 2 twice. Now the other number is 3. 6 has it once, 4 has it 0, so we will need it once. So really, 2 times 2 is 4 times 3 is 12. So the least common multiple for 4 and 6 is 12. It is the smallest number we can turn both 4 and 6 into. Now another way we could have actually looked at this is looked at the multiples of 4, which is 4, 8, 12, 16, 20, and going on. The multiples of 6 are 6, 12, 18, 24, 30. And well, the first number they are the exact same is 12. So the least common multiple between 4 and 6 is 12. And we could actually do that with any sets of numbers and just look at all the multiples and see where do they all line up first. So 12. Any questions on this here for 4 and 6? Now we need to look at the sets of parentheses. So when I look at this first one here, well, we have x plus 2 occurring how many times? Once, yes? If I look at the other set with the 6, how many times does x plus 2 occur? So how many times do I need x plus 2 in my least common multiple? Once. Any questions on the x plus 2? Now, over here I do have x minus 2 once. Over here I have x minus 2 how many times? So how many times do I need it? Twice. So I need x minus 2 and x minus 2. And we're taking care of everything in both. So this here is the least common multiple. This is the smallest thing we can turn both of these expressions into. And this is going to be very helpful, kind of having an understanding of this for when we start adding and subtracting. Now we won't specifically, I don't specifically rewrite out this is what the least common multiple is, but this thought process of making these the same is what's key for this here. Yes.
So x minus 2, the reason you want to do it twice is because of this.
Well, this one here has it. Well, we need them to be the same. Because we're trying to figure out what do I need to do to these two to make them be the exact same. So what do I need to do to make this one be the same as this? It already has one, yes? But how many does this one have? So what does this need? This has 2, this has 1, yes? If I need them to be the same, this one needs how many more? So we would have Because again, least common multiple, we're trying to get these two to be the exact same. It already has 1. This one has 2. So this one, if it's going to be the same, it needs another one, which gives it a total of 2. Well, what does this have that this one doesn't? What's missing in? X plus 2, because if they don't have it, we need to put it there. Any other questions on this? Let's look at this one here. All right. So the first thing we need to do for this here to find the least common multiple is we need to factor these. So we look at 6x squared minus 54. Is there a greatest common factor between 6x squared and 54? 6, and we can factor it out. If I factor a 6 out of 6x squared, I'm left with minus 9. Now we need to factor the x squared minus 9. And x squared minus 9 is a difference of perfect squares, which would be x plus 3 and x minus 3. So we finished factoring the first one. Now we need to factor the other one. So we need to see if there's a greatest common factor between 9x squared, 54x, and 81. And there would be, it would be 9. Which would leave us with x squared minus plus 9. So factoring this here, the third term is positive, so the signs are the same and they match the sign of the middle term, which would be negative and negative. Now the factors of x squared are x and x, and the factors of 9 that we'd want to use are 3 and 3. Least common multiple. So again, we're trying to see what do I need to do to both of these here, or what can I take from both of these to make them be the exact same. So the first thing we can look at is the 6 and 9. Now the multiples of 6 are 6, 12, 18, 24, and we can go further than that if we need to. The multiples of 9 are 9, 18, 27, 36. Well, 18 is the smallest number for both 9 and 6 that they would be the same. So for 9 and 6 to get them to be the same, I would need it to be 18. Because if I'm making these both be the same, what would I need to multiply the 6 by? 3, because 6 times 3 would give us 18. They would be the same. What would I need to do to the 9? So at this point here, both of these numbers would be the same at 18. So we've got them a little bit closer to being the exact same. Now we need to look at the sets of parentheses. So we can look at x plus 3 first. Well, this has how many x plus 3s? How many does the other side have? So if they're both going to be the exact same, I need x plus 3 to occur at least once. So we'd have x plus 3 once as part of the least common multiple. Because this one here has it twice, this one here has it once. It really doesn't matter that the one has it once. Since it occurs over here twice, we need it to occur twice. Because if we're going to make them be the exact same, this one here is missing 1x minus 3, because if we have it twice, well, they both have it twice now. This one here is only missing and x plus 3, so now this here and this here are the exact same, and it's the smallest that we can have it. We don't have any unnecessarily repeated terms. This here is the smallest and most efficient way to turn these two to be the exact same. If we use anything greater than this, we'll end up having something in common on top and bottom that we'll have to factor out later. And it'll make some of them a little more complicated. Because any set of parentheses here that we add beyond this will increase the top by a degree of 1, which we'll have to pull back out later. Any questions on this here? Let's look at one last one. Five x cubed and 10x squared minus 15x. Now 5x cubed is by itself, so there's nothing we can do to factor it or simplify it down further than, well, 5x cubed. What can we do to factor 10x squared minus 15x? We can factor out a 5x, because there is a 5x in common with both terms. If we factor a 5 out of 10, we are left with a 2. And if we factor an x out of x squared, we're left with x. Minus a 5 factored out of 15, or 15 divided by 5 is 3. And the x factors out completely. So we're left with this here to find the least common multiple. So the first thing we can look at is, well, screen will stay still, is the 5x cubed and 5x. Because those two are in common and they are being multiplied. One of them is being multiplied by something else, but we do have a 5x in both spots. Well, we have 1, 5, and 1, 5, so are those already the same? Yeah, so that will be a part of our least common multiple, will be the 5. Now we'd also need an x. Well, how many x's do we have here? How many do we have here? 1. So how many do I need for them to be the same? 3. Because if this one has 3, both of them need to have at least 3. Because we need these to be the same. Well, if one of them has 3 and only one of them has 1, well, to get them to be the same, I just need to add 2 to the other to get them to be a total of 3. We're just trying to get these two to be the same. Well, what else is this missing that this has? And that's it. Because really what our goal is to try to get these two to be the same. We're trying to see what does one have that the other doesn't. What are they missing so that we can get them to be the same? Questions on this here? Yes. And that's kind of the funky thing with this, because it is called the least, but we're really grabbing the most of each one to get the term with the smallest or least possible combination. Because this is the smallest version that I can turn both of these into, and we need the most of each term. Questions on this here? All right, let's look at the first addition problem. Now, as we look at this here, we can definitely tell that the denominators are not the same. And we need to get them to be the same. And that's really utilizing what we just did, this least common multiple. This property of getting these two to be the exact same. Now to do that, the first thing we'll really need to do is factor these. If we can factor them, we need to factor them. Now the 9x squared is by itself. There's nothing else with it. But the 3x squared plus 3x, we can factor this by doing what? By factoring out 3x, because 3x squared and 3x both have a greatest common factor of 3x. And if we factor that out, 3 out of 3x squared would just give us 1. X out of x squared is x. So 3x factored out of 3x squared gives us x plus 1, because the 3x factors out completely, leaving us with 1. 3x divided by 3x would be 1. Now again, for us to get these here, for us to be able to add or subtract, we need the denominators to be the same. We need them to be the exact same. Now, move this over a little bit so I have a little more room. Looking at these two here, what is the 9x squared, or what does the 3x times x plus 1 have that the 9x squared does not? The x plus 1. So, if I want this to be the same, well, I'm going to need to multiply the 9x squared by x plus 1. Because if I multiply it by the x plus 1, it'll be closer to being the exact same. Well, we also need to fix this one here because they aren't the same. Because over here, we have what? 3x. Over here we have what? 9x squared. What do I need to do to 3x to make it the same as 9x squared? Multiply by 3x, because 3 times 3 would give us 9. X times x would give us x squared. And if we do this multiplication, so the denominator of the first one here would be, well, 9x squared times x plus 1. Over here we would have 3x times 3x, which would be squared times. So by doing this, did we get the denominators to be the same? Yes. Now, I can't just multiply the right-hand side by 3x on bottom. We'll also have to multiply it by 3x on top. I can't just multiply the 9x squared by x plus 1. We'll also have to multiply the 7 by x plus 1. And this here is actually kind of ingenious the way that this works. Because really, what am I multiplying both of these rational expressions by? Let's use like with. Because what is this and this here, realistically? 1. Because anything divided by itself is 1. And we know that if we multiply something by 1, does it actually change it? No. So really, are we changing either one of these rational expressions? No, we're changing how it looks, but we're not changing its value. It still has the same value, we're just changing how it looks. So, over here, we're going to distribute and multiply through by 7. So 7 times x is 7x, plus 7 times 1 is 7. Over here, we have 3x squared. And now that we have the denominators the exact same, we can add the numerators. So we'd have 9x squared times x plus 1 on bottom. So the numerator, well, 3x squared, there are no other like terms anywhere for our x squared. And we'd have 7x plus 7, because each one of those terms in the numerator only appears once. Bless you. Now at this point here, we would need to make sure that the numerator does not factor in any way, shape, or form, and well, it actually works out that this one does not factor at all. So this here would be the final answer. Now we don't want to multiply the denominators. All right. So we do need to leave the denominator factored that way, because if there is going to be something in common on top and bottom, it's better to leave it in this factored form so that we don't have to multiply it out, then factor it back to see if there is a greatest common factor or something in common on top and bottom. But that's all we have to do for this here. Any questions on this? All right, let's look at another one. Okay, so obviously, looking at these two here, the denominators are not the same. But we would want to factor them so that we can get them into a form to where it would be easier to see what is going to make them be the same. What can we factor them to make them be the exact same? Well, 12x squared does not simplify at all because it's only a single term. Now we can factor the other denominator, our x squared plus x, by doing what? Factoring out in x. What can we do next? We can try to make the denominators be the exact same, yes? Is there anything else interesting with this here? Okay. So let's go on and multiply these to get them to be the same. So what does the 12x squared have that the x times x plus 1 doesn't? So it's missing the 12, and we'll need to multiply top and bottom for this here by 12. Anything else? Here we have x squared. Here we just have x. So since it has 2 and this one only has 1, we need this one to have a second x for them to be the exact same. So now will this side here have everything that this side has? So we will have the 12 and we do have 2 x's, yes? So it does have everything. Now, does this side here have everything that this one has? What is this side missing? X plus 1, so we'll need to multiply top and bottom by x plus 1. So we multiply these here. For the first one, well, we're going to do 8 times x, which is 8x. And 8 times 1 is plus 8 over 12x squared times x plus 1. Over here, we're going to have 12x times x, which is 12x squared. On the denominator, we'll do 12x times x, which would give us 12x squared times x plus 1. Any questions on how we got to this point here before we add these together? Now we can go on and add them together. So we have 12x squared plus 8x plus x over 12x squared times x plus 1. Now luckily for us here, really we don't have any common terms on top because there's only one spot where there's an x squared, only one spot where there's an x and our constant term. So again, before we finish this up, we do need to see if the numerator can factor at all or has a greatest common factor. Is there one? Well, 12, 8, and 8 do have a greatest common factor of 4. And if we factor 4 out of 12x squared, we're left with 3x squared plus 2x plus 2 over 12x squared times x plus 1. And we do need to factor out any greatest common factors or simplify it down as far as we can. Now it does work out that the 3x squared plus 2x plus 2 doesn't factor any further. But there is something we can simplify. What can we simplify? Because the 4 and 12 are being, both of them are multiplied on the outside. So we really have 4/12, which simplifies to 1/3. So on bottom we actually have 3x squared times x plus 1. On top we'll have 3x squared plus 2x plus 2. Highlight it back out. Well, we have a 3x squared and 3x squared here, yes? Can I simplify those two out? Yes. Because this 3x squared is plus the 2x plus 2. That is all one term. The 3x squared on bottom is being multiplied with the x plus 1. So if I did have 3x squared being multiplied on top, then we could simplify like we did with the 4 and 12. They're both being multiplied on the outside. That is fine. But because the 3x squared on top is being added to the 2x and the 2, 3x squared plus 2x plus 2, that is one whole term. I can't just cross those two out. And again, I point this out because I've had it done multiple times in the past where students have wanted to cross those two out because 3x and 3x in front. We can't do it because 3x squared plus 2x plus 2 is all connected as a single term. So we can't just simplify those two out. Questions on this here? We're going to stop here. I could probably squeeze